look at because I do 50 questions, scanned my basic exams in this course. So these review exams are 25 or 30 questions, which are the same format that I would use on the actual exam. And I go over these the day before the actual exam. And I actually use a lot of these questions on the exam. You don't know in advance which on the exam. So that would be the key thing to study right there. And then, of course, if you can't answer a question or something like that, we can talk about it, or you can use some of the other review materials. And there is an answer key also for the, it's the same thing with these little asterisks to indicate which was the correct answer, but I don't recommend looking at that one first. You really should look at the one that doesn't have the answers and think about it, because it'll be a lot better if you really internalize what's going on. Clearly, it's all about learning here after all. That's just memorization. Okay, so again, just to pick up a little bit more to say about what's going on Mars these days. There's of course, you know, we've been interested in the possibility of life on Mars for many, many years. Even historically, astronomers, as we'll see, thought they saw canals on Mars and thought they saw the evidence for intelligent life on Mars many decades ago now. But in the modern era, we have lots of evidence that suggests that life could have existed on Mars, or perhaps even does exist now. We can't rule that out at the moment. There's lots and lots of stuff. I could go on for hours about this, but I won't do that at the moment. But for instance, well, I mean, there's different types of water. There's water that can be contaminated with different types of material, acidic water, things like that. But several years ago, an orbiter around Mars came up with that. Can't quite hold it up yet. But anyway, a giant pool of water ice. So this is kind of like something comparable to the North Polar ice now on Earth at Mars' south pole. So when we look at Mars, what we actually see, actually not so easy to see right here, but we'll see other photos where you can actually see there's a seasonal variation of polar caps from the north and south poles of Mars. And so anyway, we know that a lot of that actually is frozen water. It didn't have to be frozen water. It could have been frozen carbon dioxide under those conditions. But we actually know that there's a lot of frozen water on Mars right now. And I was reading about that this morning. If we took all the water that's on Mars right now that we know about that's on the surface and distributed it over Mars's surface as a uniform layer, it would be maybe about 50 meters deep. Okay, so that's a lot of water. It seems like a lot of water. It is a lot of water. 50 meters worth of water spread over Mars' entire surface. Now, just by comparison, if we did the same thing with the water on Earth, we'd have a layer about 2.5 kilometers deep. So the Earth is a bigger planet and has a lot more water than Mars does, but the amount of water that Mars has is still very, very significant. And it's the only other place we know of in the solar system, at least the only other planet, which has water in any form at all, like we have water on Earth. So that's very significant. So we know the water's there. We, of course, that's something we think is essential for the evolution of life on Earth. But another material has been in the news lately. It's not really, it's not really a lot of pizzazz to methane. And it's not really. They're not facing any series about people living in methane environments or anything like that, as far as I know, unless they really get tested for ratings. But methane, as we know, is emitted by microbes on Earth and also to other things, including cows. So we almost completely ruled out the possibility of cows on Mars at the moment. But microbes could possibly exist on Mars. We don't have the technology to detect them as they're deep underground at the moment. And microbes give off methane on Earth. So the fact that we see a methane signature on Mars makes us wonder if there could actually be microbial life on Mars. And that's not to say there aren't other explanations, though. And actually, even the question of whether we're detecting methane is an open question at the moment. But what we see here is an enhanced photo. I think this was a ground-based photo where we're using infrared detectors to determine that we're seeing a methane signature on Mars. Okay, so the thing about methane on Mars is it doesn't last very long, because it actually, well, I don't want to sort of read this entire thing here, but somewhere in here, trust me on this, there's a statement, well, for example, here, methane molecules are easily blown apart by ultraviolet light from the sun, okay, which of course eliminates Mars. But there's also Martian chemistry. Mars has a highly oxidizing soil which tends to rip apart methane. So the point is, if you see methane, there's got to be a source of methane because it gets destroyed. right? It actually gets destroyed over a period of a few years. So if you see any methane in the atmosphere of Mars, it had to have been created within the last few years. There's a possibility that there's actually a geological origin to methane on Mars, which we know there's a possible geological origin on Earth, some of our methane. Moreover, okay, we have our Curiosity rover on Mars. Remember, Curiosity is the sort of the Prius that's running around on Mars right now. And one of the big things that they did with that, all the way back, this was like in August of last year, yeah, towards the end of last year, they used a very sophisticated instrument on Curiosity to test for methane, because there it is with this fantastic, incredible laboratory rolling around on Mars. And they find none. They didn't find a trace of methane in the area where that particular, maybe nice photos here, but in the crater where it's living at the moment, this Gustav crater, there's no methane in the atmosphere. But there's probably not too much anywhere else on Mars because the atmosphere is too mixed. Okay? So this is a mystery now because we think we detected methane, but now with an actual instrument on Mars, we're not detecting methane. So all the NASA scientists who are going crazy, jumping up and down, saying there's probably microbes on Mars, now we're back to this big guessing game again. We really don't know for sure because with a lander on Mars, we're actually not detecting methane, which just goes to show you that even with modern technology, we're still talking about the good old scientific method here. We're making observations, we're making hypotheses, and we're testing them. And in this case, the hypothesis is that we're going to see, methane on Mars because we think we detected it with telescopes from Earth, but we're not seeing it. So one possible explanation, by the way, is that the way that we detected methane using a telescope might have actually been contaminated by looking through Earth's atmosphere. Okay? Because when you're using a ground-based telescope on Earth's surface, of course, you're looking through Earth's atmosphere. And there's a technique called spectroscopy that we'll talk about in detail, which you use to detect substances. Well, if there's methane in our atmosphere, it could have contaminated the observation. It's kind of a no-brainer, and that was thought of. Some precautions were taken to deal with that, but it's not clear that the precautions were actually adequate. Okay, so this is just a little slide about the methane cycle, just to give you an idea that there's production and there's creation and destruction of methane. We think we see it in the atmosphere. Okay, it could be destroyed by ultraviolet radiation from the sun, as I mentioned. Also, oxidation from surface chemistry can destroy it. So it can disappear very readily. Where does it come from? Well, possibly some kind of exotic chemical reactions involving the Martian geology. Or maybe microbes, but we just don't know. We probably won't really be able to tell with surface devices like Curiosity. We're probably going to have to actually drill into the surface of Mars to get to a layer where we think microorganisms could survive, because they can't survive on the surface. This ultraviolet radiation is Mars. The surface is pretty much unshielded from ultraviolet radiation. There isn't any ozone layer like we have on Earth to protect critters running around on Mars. So probably not microbes on the surface now because the atmosphere is very thin, but it may have been very thick in the past. And this leads us to these chunks of rock known as the Martian meteorites. So we'll talk about this in more detail when we get to the Mars chapter. But the Martian meteorites, we believe, are from Mars, actually because there's gas in those meteorites which matches the gaseous composition of Mars' atmosphere. So we can tap these little bubbles in these meteorites, which are found at the south pole of our world. Okay, we happen to find these meteorites at the south pole of our world. And if we tap into little air bubbles, we can match the composition with what we measured using Viking experiments on Mars in the late 70s, when you were all little. Oh, there's the pole. See? Look at there's the pole. That's actually the North Pole right there. Now, when we cut into these meteorites, we see little things that look, well, sorry, just a second. Oh, this is just talking about the Martian atmosphere. Just a second. The Martian atmosphere today is unlike our atmosphere, entirely unlike our atmosphere. You can see that it's about 96% carbon dioxide. Okay? So carbon dioxide is like less than 2% in Earth's atmosphere. You don't see a lot of free oxygen. In fact, we see about a lot less nitrogen. Nitrogen is about 78% of Earth's atmosphere. So it's a completely different atmospheric composition, but it may in the past have been much more similar to Earth's. And by the way, what we're seeing here are kind of percentage bars, but the actual, if you add up all this stuff, it's still only about 1,000th of the pressure of Earth's atmosphere. So, it's like 96% carbon dioxide. I think that's a lot of carbon dioxide. It's just a large percentage. There's really hardly anything there, in sort of practical terms. But that's the atmosphere that we see now. There may have been a different atmosphere, and this is a cutaway of one of those meteorites, and people were seeing these little things that look like microbial fossils, and so the imagination, human imagination being what it is, and everybody, including scientists, there was speculation that these could be actual fossils. And also there's a certain type of organic compound associated with this, which also is associated with life on Earth. So we'll be talking about this a little bit more when we talk about, go through the chapter on Mars, because it's an interesting application of the scientific method, as well as examining possible ways in which life could evolve. So there's just one close-up picture there. And by the way, we don't think those actually are fossils, because as it turns out, we see things like that in rocks that were taken back from the moon by the Apollo astronauts. Okay, so if you see a feature like that in a rock from the moon, it probably has nothing to do with life, because we're practically absolutely certain there was never any life on the moon. So it's sort of a counterexample that argues against that possibility. But there's no doubt that there was a lot of running water on Mars in the distant past, probably something like 1 billion years ago, or at least hundreds of millions of years ago. We see features on the surface of Mars that look just like runoff features on Earth. All sorts of things, river deltas, streams, islets like this here. But we don't see any water on the surface of Mars now. It's virtually a desert except for at the poles. But there is an interesting exception to that. Orbital images now have zeroed in on certain crater walls. And what we're seeing here is a wall of, I think this is crater Newton, if I remember correctly. And you see these wispy looking things here. Just the structure of this looks like it's not very old. Because there is wind erosion on Mars. There's a wind, it's a thin atmosphere, but you can have a pretty high speed wind. So if you have anything sandy and fine like that, it's going to get obliterated pretty quickly. So those fine structures kind of look like water's been oozing around there. And then, amazingly enough, we now actually see evidence for the actual motion of liquid water on Mars. Because these features here, these kind of stains here, vary seasonally. They dry up and they're gone, and then they come back. So it looks for all the world like water actually is leaching out of the wall of that crater and descending down the bank there. And there's a few different videos that I'll probably want to show. The first one, which is kind of cool, that discusses this phenomenon a little bit.